Alright, so with our animatic done, we can start working on some shots. Now, here we have our storyboard, and now you might be inclined to start with shot 01 or shot 02. For this tutorial series, we're going to start with shot 030. Reason being is that this is going to be a good shot to sort of explain Vellum fluids and some use cases of like how it works, explaining the parameters and stuff like that, because we're just going to have some lime and some fluid splashing over it, and we can just use the lime as a collision object to just try some stuff out even before we even start doing any of the actual simulations. So I figured that would make more sense than doing a separate scene to just demo out the solver. We can just start with shot 030, then I can do some initial explanation of how the solver sort of works, what to pay attention to, and then we can actually build the shot, so build shot 30. And then after that, we're gonna move back to shot 20, because here we're going to have the leaf hit, and the leaf hit is also something that we're going to be having in shot 1, where some of the leaves in the environment will also be hit with some droplets. So we're sort of going to work our way backwards in this case first. So 30, 20, 10. And after that, it's still up in the air over which ones we can do. We can probably do shot 040 afterwards, so sort of as a nice little intermission with the rigid body, so we get away a little bit from the Vellum fluids. And then after that, it's going to make sense to do 50 to do sort of the swirl. And then once we have the swirl set up, we can implement that in shot 60 for the side swirl. So that's how it's going to go. So let's make a new Houdini scene, and let's start with shot 30. All right, so I've opened up a new Houdini here. So this is an empty scene, and let's save out this file to our shot 30 location. So again, that's just here in this folder. You could go to $root, or not in this case yet, because we haven't put down the shot setup. If we had pasted that, we could already do that, but let's just first save out our thing, correct folder. Just call it, I guess, SESI-Snacks shot 030 underscore V001. Let's go to our animatic scene. Just go up a level. Let's copy and paste this shot setup we had from before. Let's paste it in. Let's call it shot 030. There we go. And now if we had pasted this down, we could actually use $root. So if you did that before, you could have used $root to go to the correct folder. And let's just copy this entire setup that we have here with the lime. So in this lime, here we have, of course, the small green lime asset that we also need. So what we need to copy is shot 030 and the small green lime asset. So let's just select those both, Control C, go to our other scene, and let's paste it in. Then I guess we could do some organization here of, again, putting this in a tab and call it models. And then we have our shot 030 here. And we could probably just take this out of the subnet, because we don't necessarily want it in the subnet here, because now we're just going to be working on one single shot. Let's just lay this out with Shift L on the keyboard. And we can get rid of this empty subnet here. And this is now not linked up to the lime anymore. Let me just go to my correct view here. So again, with the split thing that you could have saved out before if you went to save desktop, and he comes here in the list. Go to object. Let me go to lime, and let's merge in the asset geometry over there. So then that is loading correctly. We have the environment limes here. And also want to load that in there. So, all right, now let's see. Yeah, now we're back to where we were before, but now on regular object level. So yeah, now let's talk a little bit about the Vellum solver and doing some Vellum fluids. Right, so let's just hide some of this stuff. Let's copy and paste our flip. Let's call this Vellum underscore sim. Go in there. And let's delete all of the other stuff here. Let's just set up some simple simulations in here. So let me just go into the Lime real quick. So this is being merged in there, all right? This Lime is quite small, and that's probably not going to be great when we're doing our simulations. We probably want to sim on a slightly larger size, just because generally once it's basically the case for almost every simulation inside of Houdini. If your scene scale is too small, it's going to deal with a lot with exponentially smaller numbers, which gets less accurate. Like if I have a particle going from here to there, it's going to be, for example, it's going to be a very small, like a 0.001 increment increase. Well, if I were to work on a larger scale, it might be 0.1, 0.2. So the precision of the float operations is going to be like a lot higher if you do very small. So it's generally always try to sort of set up your scene scale that it's like, it doesn't have to be real world scale. Generally just try to work with very small scale stuff, just scale it up a little bit and then just sim it on there, and then make sure to increase your forces, for example, and then just try to get something realistic, and then you can later scale down your actual your actual scene again if you want. But in order to set this up, let's create a sphere. So now you can see the sphere is actually a little bit of a normal size. If I didn't scale this up, the sphere would already be a lot larger than the Lime, so it's already a lot better. And let's do a Vellum source grain. Vellum configure grain. So let's say Vellum configure grain source. And this is going to create grain from our sphere. And we want to enable create points from volume. And as you see by default, it's going to be set to grain. Let's, by the way, do some null here so we can view the attributes. And say geo and con, just good habit. Let's check out the point. So if it's set to grain on here, it's going to be set to is grain. And if we put it to fluid, it's not going to be set to fluid. And then you can see it has different attributes on there. So for example, the face here is only going to be on a fluid. So Vellum will know that it needs to solve it as a fluid. So let's put it to a fluid. And we probably want a little bit more points. So it's set to 0.01 for now. Let's put it to 0.05 or probably 0.2. All right, so you have some more options here. You have, for example, jitter scale. Like if you want to add some jitter, you can jitter it a little bit. All right, let's do a Vellum solver. And let's plug this in, plug that in as well. And by the way, on the constraints, since there's not really any primitives, there's not really anything there. There's not really any attributes on there. So, yeah, I'm not sure how much of a difference it even makes. Plug it in, but let's just plug it in. And let's plug that in. Right, so if we now just zoom out a little bit and let's plug this in. Right, so if we now go back and we just play this, it's gonna hit it and then sort of suddenly explode, which is probably not what we want. It's not like fluid at all. So what I was mentioning before is that if you have flip fluids, you have a sort of a volume sim and then particles moving through it. With Vellum is going to be very different. So each of these points has its own calculation happening. The problem is one calculation per frame is not going to cut it if you're going to do fluids this way. Let's just try increasing it. So let's go to Vellum solver and let's put it to 5 substeps. Still not going to be really like fluid, but it's going to be at least a little bit better. And what I also noticed is that you also have these constraint iterations, but when we have fluids here, there's not really any proper constraints there. So what I found when doing Vellum stuff, at least if you're not mixing it with other like other stuff, if you're just using fluids, can generally turn down the constraint iterations quite a bit, because there's not really any constraints now in this scenario. Like there's no primitives in between here trying to keep this together, so you can generally turn that off a little bit, and then once you increase the constraint, the substeps, it's just going to be a little bit faster. So this is of course still not like fluid at all. So let's go into our actual physical attributes here. Let's talk a little bit about all this individual stuff here. So a whole bunch of stuff here. Viscosity is going to be how thick the fluid is. Surface tension is going to be sort of the fluid pulling on itself to sort of pull it together. Like if you have a droplet on a leaf, that's going to be a high surface tension area, or just a droplet in general, like what we're going to make here. So these, right, this stuff over here is going to be high surface tension. So that's definitely something we're going to be using. Friction is going to be the friction once it hits something. There's also dynamic friction. I'm going to be honest, I'm not completely sure what that does, if I'm honest. Repulsion weight is going to be how much the points repel each other. We don't necessarily need that for our fluids, but probably if I increase this, you can, not sure if you can, if it's going to make a difference here, but it's sort of the force that points are going to repel each other. We don't necessarily really need that here. Let's just leave that to 1. So let's just start experimenting with some of the stuff like viscosity and surface tension, because those are going to be the most important. So let's set viscosity to 1. It's probably not really gonna do much yet. Let's increase this to 100. And now you can see it. So the thicker you make, it's going to be sort of more. If you make it really thick, it's going to be a lot more honey-like. Let's just first put this to something like 1000. You can see this is going to get a lot thicker. And something I noticed myself is that I like putting physical attributes here to just calculate uniform. Density is going to really influence the way this stuff behaves. Surface tension as well. So let's just first set it to density 1000. Let's just play. So that's how heavy each point is going to be. And you can see I prefer setting to calculate uniform. You could probably also get it to work with set uniform, but calculate uniform 1000. You can already see how the mass here is going to get quite a big difference. You can see it does slide off here quite a bit. It has to do with the friction. So let's increase friction here. Probably want to increase that a lot more. Let's try 100 for now. Might start acting weird, but we'll see. Right, so you can see now with some higher friction, it's gonna stick in place. So now we have sort of a even thicker than honey-like substance. But the point what I was trying to make, like density really influences the way this behaves. So if I turn, like say I put this to 10, you see now it's just going to be sort of a hard ball, and it's sort of even bounces off and it sort of stays into place. It's because these points now are very light because we really turned down the density. So it will now it's more acting like sort of a piece of just very hard mud or something like that. Well, if it was like very high, and you have to keep in mind that if you make it too high, you can also have other problems later with the surface tension. We're going to get to that a little bit, but let's first experiment a little bit with just seeing what this stuff will do. But something like this, you can see it nicely flow over, get some sort of a honey type thing. Let's decrease the viscosity a little bit. So this is something like you would you could make something just thick substance or some honey. Not that we need that for our shot, but that's how you do sort of a fixed substance. So there's also surface tension, and what surface tension is, like I mentioned, is you have to sort of imagine that sort of each of these like there's sort of a let's imagine there's sort of a filament around this thing, and that's trying to sort of pull it together and keep it sort of in this shape. So it still has, let's say if we turn viscosity off, it's still going to have a low viscosity, so it's still like water, but it's kind of like it's in a water balloon or something. And if it then splashes off, it can create sort of individual pockets that also have surface tension. So that's why it's great for stuff like these splashes. So let's experiment with this a little bit. Let's turn down our density a little bit. So this is also really going to influence the way that our thing behaves. So let's turn surface tension on just to 1. Let's just zoom out, and let's just see what it does. All right, so if we press play now. Oh, and this is really exploding. A couple of things. Probably need to turn down friction a little bit. Let's put friction to 1. And this is still exploding a little bit. So this is where sort of this density is really gonna come in. So this is really just exploding. You see. Let me just maybe flipbook this. And this was something that that's mostly what was difficult trying to sort of get the Sims to look right. It's really a fine balance of all of this stuff. So this is with surface tension like high and low friction, with a density of 1000. Let's say we just put this very low. So meaning that the fluid that is going to fall is going to be very light. Let's just press play. And you can suddenly see it is a lot more stable. And now we actually get all these tendrils. So if you compare that here to what I had before, and it's just the weight of the fluid. So now it's really exploding. And now we have it here. Boom. We actually get some nice tendrils by just making the fluid lighter. So it's always going to be a very fine balance of like how dense do I make my fluid? How many substeps do I have? Because I could also, like, probably if I make this higher, let's just see if I put this down, and let's see if this will still, okay, so this is still quite fine. But if I make it too high, let's try 750. Eventually, because the fluid then is just going to be too thick, it's just going to explode. Boom. And then, like, you might think, oh, how do I solve this? Like, it might also in some cases be that, you know, right, maybe I need to increase the substeps. Now, I'm not sure if this is gonna fix it in this scenario. Let's just see. So you can see this does sort of fix the initial burst, but because the density is still quite high and it's sort of trying to keep the surface tension with these things, but each of these individual points are going to be quite heavy, it still doesn't give us these super nice droplets. Let's just turn these down. Oh, turn these down a little bit again. And then in that case, it might make sense to really decrease the density. This will also mean that if you're going to mix later soft bodies in here, that you're going to also need to play with the densities there. So it's just basically, I know them sort of like there's no exact sort of sciencey way to sort of do this. It's just really playing with it. Eventually you get a hang of the parameters. For example, I could, like, let's say if I now increase the surface tension. Yeah. Still not perfect. Like, you might even think, right, let's add a little bit of viscosity here. Like, it doesn't have to be physically accurate as long as it looks good. Let's just do it without. But anyway, point being, density and surface tension are really important together. So play with your, if you're doing high surface tension, I generally don't make it too high. You can see with a low density here, it's going to look a lot better. Now you have this face thing here. This is explained in more detail if you go on the SideFX website or on SideFX YouTube. There's another tutorial series there about Vellum fluids where they're using this specifically. Essentially, this is setting it to sim as a separate fluid. So let's say if I had another fluid here with a different density and I want to mix them, I want to be one on top, I could set it to phase 2 and then, for example, make the density higher, then that one would be at the bottom. So for that, you can check out the SideFX.
So to start with,
this one, I think it's this one. Yeah, so here you already have a demo when they're actually sort of mixing two fluids together. So that's where phase comes in. So we're not going to be using that during our little tutorial thing because our fluids are going to be as heavy. We are mainly going to be focusing on just density of certain objects, mixing them together. But yeah, those are the basic parameters here. So for this shot that we're going to do, this is roughly what we're going to be needing. We're going to be needing roughly like somewhat low density, somewhat high surface tension, a reasonable amount of substeps, probably higher than this, like probably something like 10 or 12. And then we should be getting some nice tendrils. But we do need to do a little bit more in order to actually make the shot that we want to make. Because the problem that we're going to have is we're just going to drop a droplet on here, something like this. You can see it's really sort of just a one single splash and that's it. And what I kind of want is I want to actually keep emitting the fluid for a little bit longer so that I get sort of a thicker fluid edge. So I want to sort of push it down, maybe with some velocity that's sort of going to splash off of this. Maybe we can even add some extra velocity here. So we're going to get a little bit more fluid than we can get with just one drop before we, I guess we can make the droplet a lot bigger, but that's going to look weird as well. So we're going to emit it for a couple of frames. And then we're going to do the surface tension thing. Now, you might think, all right, how do we emit for more frames? Because that's actually not really possible in here, right? By default. So there's something different we need to do there. So in order to emit continuously, not omit, we need to reduce these there. And we need to go into the Vellum software and probably need to, because else it's going to error, to probably just add a null on there. But just a null that doesn't sort anything. So now we can just play and it won't error. So if we don't do that, it's gonna... Oh, no, now it's not gonna error anymore. All right. So initially, this was erroring in an older build. But I guess if you want, you can still put this in. So in an older build, this was erroring if you didn't plug anything in. But I guess they changed that. So that is actually quite nice. So let's just go in here. Boom. And we can add a Vellum source in here. Vellum source. Let's connect it up. Boom. And this one's a sub path. And let's go. We need to actually go in here. So let's put in this source here our geo and our constraint path. So now you can see it's back in here. But if we're gonna play, see, it still only does one frame. And by the way, let's for now turn down the, to make it a little bit faster, let's turn down the substeps for now. Let's do a little bit less particles, which is a little bit easier to, faster to work with. So it's still emitting only one frame. So what we need to do is to go in here, emission type, and you can pick different things, each frame, each substep, or well, any of the other things. So by the way, before we start actually doing our actual regular sim, now that I'm thinking about it, we actually haven't set up our shot here correctly, which is a little bit stupid. We should have done it initially. So let's do 30 frames per second. 1001, and let's do last frame 1150. Right, so that's first order of business. Make sure that our solver here is set to start frame, say 1001. Right, so that is now solved. And emission type, we want to say each sub-step, or you could say each frame. So if you do it each frame, it's going to emit each frame. Each sub is going to do each sub-step. Let's just have a look what both are going to look like. I'm going to turn down the points a little bit more for now. I just want to keep this a little bit faster while we're recording. All right. So you can see now we're emitting over our line. You can already see this is already starting to look a little bit more what we want. Like we get these sort of nice splashy edges here. So we look down here. Yeah, if we look down here at the bottom, if we play, that's already probably a little bit more what we want. The problem is, if we keep playing this, it's gonna keep falling down. So we probably want to reduce our gravity. So I guess go to gravity. Maybe, you know what? For now, let's just turn it off. Now, if we're gonna press play, you can see nothing's gonna happen. It's gonna float around, just gonna be pushed out a little bit. Probably not what we want. So we probably want to start giving this some initial velocity on the points itself. Let's do attribute grade on here. Say v or velocity. Let's make it a point. That's correct. Let's make it a vector. Let's add some velocity, like let's say -10. Maybe that might be too much. I don't know yet. So now it's gonna source velocity downwards at the start. So now you can see if we look here, now we get sort of a real sort of sploosh. Right, that's probably a little bit more what we want, but we don't want to continuously keep sourcing this because we do want to sort of an outer layer here, right? And then some stuff in the inside. Let's say, all right, maybe we want to do this for a couple frames. So let's say $F is below, let's say 1011. Let's just try that. So now it's only going to emit until it hits frame 1011 and it's going to stop. All right, and maybe we do want a little bit of gravity because now it's really just floating over there, or maybe we don't. You know what, let's wait with that decision for now. So right now it might actually look pretty decent. Probably do need to increase the points a little bit now. It's going to be hard to get a good look at what our thing looks like. So it's all looking a little bit generic here. So you probably want to add maybe a little bit higher density and maybe a little bit more surface tension. And maybe we actually do want some viscosity here as well. I know that's not particularly accurate because we're doing water, but maybe it will help have our particles stick together a little bit. And that is something that we do want. We don't want them to explode out too much. It's already looking somewhat more like we want. The only thing I don't like is we get this sort of really uniform circle thing. So maybe what we want to do is say pop force. Let's add some amplitude. And we don't want this to sort of be a generic amplitude because problem in there is that we want this to, well, I mean, I guess we can try, but I think I'm gonna want to drive it a little bit more by what's happening on screen. So let's just play, see what's gonna happen if we just do it with some regular amplitude. Right, so it is breaking up the uniformity here a little bit, but it's, you see, it's really sort of really constantly flowing through it. I don't think that's what I want. Let's keep it to 5, but let's multiply this value that we have here. So amp, say amp times equals, let's do it by the length of the velocity. So this is gonna calculate the length of the vector. So so here you have the vector of the velocity. So moving down. And the amplitude is going to be higher when the velocity is high, and it's going to be lower when the velocity is low. Right, so let's have a look. All right, that's way too much. Let's try amplitude of 1, decrease the roughness, and maybe we don't want as much velocity going down. Maybe we do want a little bit of gravity, like minus 1.5 or something like that. Again, you don't have to exactly match all my values. I know a lot of people will do that, but try to sort of create your own. And this is essentially what your job is. If you're going to do this type of work, you're going to really just play with these values and then just try to get a nice look. And you can already see this is starting to already look a lot better. You see, we're going to get these, we're really getting these sort of tendrils that we're after. That's looking quite nice. So maybe what we could do is try to do a slightly higher resolution sim of this thing, and just caching it out. And maybe one more thing that we want to do is maybe do a little bit of drag. So drag force is gonna sort of reduce the velocity over time. So then it's gonna sort of, when it splashes outward, it's gonna slow down a little bit. So let's do 0.1. Let's just try that. And then after that, we're gonna try to cache this out with some more particles. Let's just see what this looks like. Right, so I'm actually kind of liking it. I think maybe even the scale of the noise might be, like, it might be a little bit too extreme. Okay, we could say 0.7. Let's go out of here. So let's increase this particle, or decrease, to be honest, decrease this particle size. We get some more points. Let's do dop.io. Oh, let's do Vellum IO. That might make more sense. Link Vellum to that. Right. Location. Oh, I'm not sure if we set $job yet, but let's go to File, Set Project. Let's set our $job to our $hip location. I like caching to $job. If you see my VFX folder, structure folder, you know what I mean. Because if you use a render manager like Deadline, you submit your hip file to the repository, then $hip is not going to match, because the hip file will be in the repository, so you cannot use $hip there. So I always try to use $job. So then I just put $job to my hip location. All right, so let's put it to geo, Vellum fluid 1, and then Vellum fluid underscore $f4.bgo.sc. So we get the frame range. We don't, of course, need this entire thing. I don't, because we're going to retime this as well. Let's try 1050. Maybe we need a little bit more substeps for this thing. So let's do 10. And I'm just going to sim this and then see what it's going to look like. So save to this. All right. Starting to look somewhat cool here at the end. I'm going to play a little bit with the parameters until I get something I like. And I'm going to report back after that to show you what I've done, because I don't think it makes sense to keep recording every step. So I'm going to be back once that is finished. All right. So I have finished this simulation for now at least. Which I think looks pretty good. And disregard the timing because we're going to be retiming this. But I think it looks like the look is pretty similar to what I had before. It looks quite nice. Like there's not the super round edges, so there's some sort of look to it. You can see there's so we have these sort of smoother edges here, and then we have this stuff in the center. So let me talk you through the stuff that I changed. So let's just walk through everything. Well, first I have reduced the amount of points, and let me quickly explain because I don't think I've iterated on that before. More points is not always better. In my final shot that you saw earlier, a lot of shots actually had relatively few points. The thing is, if you have too many points, it's also going to determine, because remember, calculations are going to happen on every individual point. And all that matters is if we can get a nice mesh out of it. If we have more points, it's going to be more points acting as forces upon each other, which means we also will probably get a lot more very small droplets and stuff like that, which in this case, we probably don't want. So in this case, I kind of like these sort of bigger sort of chunks we have. So in this case, I ended up reducing the amount of points. So I put it to particle size 3035. The velocity is increased, so I'm splashing it a little bit harder on the thing, so it gets pulled down a little bit harder. Now, if we go in here, I have actually changed quite a bit of things. You might notice here a pop attract. So what I'm doing here, and actually also used that in my original file. If I go over here, so it was my original. Actually, all this all had it there. What I'm doing with that thing is what pop attract does. Pop attract will attract points to it. So if you have it here, it will attract particles to it. So that's not what we want. What we can instead do is the force scale. We can make it negative, which means it will push it away. So you can see that really happening here. So it's pushing it away from the lime, meaning it will not really stick too much here. It will just hit it. And then we have this pop attract, which is put in the center and will push it away. Another thing that plays into this is on the constraints, the friction, I've just turned it off. So there's not going to be any friction anymore. So there's that. On the pop force here, just played around with it a little bit. I'm decreasing the value over time. So initially here it's 3 and then I'm turning it down. Swirl scale, I've reduced a little bit. I've turned off the roughness, which means we will get like more of a regular sort of noisy shape. If you add the roughness in, it's going to sort of have rough patches in it, which might create some more spikes and stuff like that. And I played a little bit here with the air resistance. Aside from that, used 6 substeps. There's a little bit of gravity still, and that is basically it. So I just mainly played around with the settings, and like I mentioned, it wouldn't have made sense to just record all of that. Again, if you don't match these parameters perfectly fine, that doesn't matter. Like, as long as you get something that you're happy with, it doesn't have to be exact same as mine. If you want to add some more forces in here to like make your own, it's also completely fine. But for now, I think this is looking pretty good. Again, the timing is not great because we're going to be retiming this. So let's call this sim for now finished. And now let's retime this to sort of match with our actual animatic that we did before. So what we had before is, of course, we scaled this lime up here before we did the simulation. Now probably what we want to do is want to transform it down again. Before we do that, maybe do a Vellum post process. And we're not necessarily going to use anything of the post process, but it will just take up all of these 3 inputs and then just have some processing stuff here that we're not really going to be using. Like, we're not going to be using any of this, but it just gives us one output here. It's a little bit cleaner. And let's now just transform it back down to 1. So then it's going to be, and you can see it's, all right. So the viewport is breaking again, I think. So I mentioned that before. Sometimes viewport will break. You can just close your viewport, make a new viewer. And there we go. And you can see the visualization here because we scaled it down. It's sort of keeping the original visualization. So I guess what we could do is before or after we do that, we can say, right, add or f at p scale times equals 0.1 as well. So then we're going to get back to the p scale that we had before. Or if you want to play with your visualization, you can increase it in size. Let me make my background dark again. Right. So now we can look through our camera. Right. Looking pretty good. Let's show other stuff. Let's move up a level and let's show these limes. And let's link our view to the first view. All right. Right, let's do a, oh, and this is, by the way, we might have to resim this, by the way, because this is something you're going to run into now. And I already know that we're going to run into this. So, so just be aware that we are probably going to be retiming this. Put a time blend here. We need that for the retiming. Let's put input frame range to 1001 and what do we sim again? 1050. All right, so we have this thing. Now let's do a time shift. And the only thing why we need this time blend is if you don't use time blend and you turn integer frames off, you cannot do substeps. So like if I drag through this, you can see nothing happens here. It's because you need intermediate frames, and time blend will calculate the intermediate frames. So let's scrub through this. You can see now we can actually scrub through it. Now let's see if there's actually going to be something wrong, because we might get away with it. Let's see if there's going to be a weird issue. All right, let's see if there's going to be a weird issue with retiming this. Because I know there is going to be a weird thing that sometimes pops up, and I guess in our scenario now, it's not going to give an issue. But let me just force the issue, so then I can at least explain what I was going to talk about. So on the solver here, if I go to the Advanced tab to Fluids, and I see that, all right. So by default, in the earlier builds, in the beta where I was working on, so I guess they disabled it, spatial sort interval was turned on. Let me rerun my sim with spatial sort interval turned on. Then you can see the issue, and I'm going to explain exactly what it is, because this is something we're going to be playing more with during the entire course. So let me just rerun the sim with the spatial sort interval. I'll put it to version 2 for that. All right. You don't have to repeat after me. Just have a look at the final result, and then you know what's up. Or you can repeat after me if you want, but not necessary. All right, so we're back. So I've resimmed it. Just zoom out here. So there should probably not be too much of a difference if I'm gonna switch between versions. So here's version 2. Let's do version 1. You see a little bit of a difference, not too much. The difference is going to be where if I go to my retiming, and if I'm now going to scrub to it, start at 1001. Let's go start scrubbing through this with some substeps. So still looking good, still looking good, still looking good. Still look, all right, there you go. So you can see what's happening here. After frame 20, we're getting this weird boop, boop, boop. Okay, so what this is doing, I'm actually surprised that they disabled it by default, because it is actually a quite nice feature to have. You might think, all right, this breaks it, I'm gonna always leave it off. But what spatial sort intervals is, let me just read it from here. So vellum fluids and grains perform many calculations involving nearby points. Generally, performance is greatly improved by ensuring that points that are near other in 3D space are also near each other in memory. This option enables a spatial sort of particles and specifies the interval. So what it's going to do is that every 20 frames is going to resort the particles to be close together. So let's say we have some points that are, when we start out, like they're all together here, but a point that's going to be over here, if I just scrub through it, they are close together in the beginning, one might go over there and one might go over there. So they're not going to be close together in space, which is going to significantly slow down the simulation. So what spatial sort interval will do is it will sort of sort the points in 3D space to be close together. And if you're just playing through it, just without doing anything, like you don't notice it just plays. But if you're going to retime it, then you will notice the sorting, because after the interval passes, like it's going to resort them from the old place to the new place, because it did the sort in memory, and that's where sort of the issue comes in. So if you run into that issue, and again, we didn't now because they have disabled it by default by now, which is perfect for this scenario, which I didn't know yet because that was changed. If you disable it, it will not do the sorting, and then you can just retime it properly like before. But sometimes you might have great speed up by having this on, like if you don't need to retime and you have a ton of points and stuff happening, spatial sort interval can really help speeding up your simulation. So anyway, just wanted to throw that in there because it's quite an important thing. It was something that I was running into constantly when I was making my shot. So there you go. So anyway, let's unhide all the stuff here again. Let's go look through our cam. And we probably want to do some timing. So let's say that here we want to start the splash. And again, like I know there's we don't want the stuff that's going on over above there, but we're going to cut that off later. So let's say, at around frame 7, we're going to start the splash. So over there, and we're going to do, so we're still in the movement here. So let's say in frame 1014, let's say we're going to have this, and we're going to do very quickly this big splash. And then we're going to slowly move this out. Set another key. Have a look in our keys. And maybe you want to something like this. All right. So we're going to have a ramp in. Then it's going to slowly, and it's going to ramp off and be really slow. So let's play. So fast and then very slow. All right. So one frame before this, we probably want it to just be this little sphere. And let's by the way do the one frame after. Let's try. Let's try 1008. Let's just increase because I want the start of the splash to be the next frame. So let's just walk through it. Right. And then it does that thing, right? So now we've just retimed it. So here we have a drop, then it hits it. And then of course we wanted to, in the frames before that, want to move it up. So let's go over here. Let's do center to origin. Let's zero it out. Let's key our Y position. Let's move forward a couple of frames and let's just move it upwards there. I guess we could say that we wanted to ease it in. All right, looking pretty good. Probably, if we're looking at it like this, let's flipbook this real quick to see what this looks like if we're just playing it back for real. All right, start. All right, so actually it looks pretty good. I like it. Actually, I want to add a little bit of animation, I guess, to the lime, because now it's really. So I probably want to do a little bit of rotation on the thing, and probably it doesn't matter if we just rotate the lime itself. So let's rotate this, because again, we're not like we're hitting it, but we're retiming it. It's outside of the frame, so it's not going to matter if we just rotate it a little bit initially. So let's just go to a little bit before this whole thing. Let's rotate this just slightly. So like that. And then probably want to rotate it inwards when it's moving down. Let's go up a little bit. Let's rotate it like that. Open up the animation editor again, shift click. Like that. And then we probably want to ease that rotation. Let's maybe move it forward a little bit. We probably want to ease into that rotation. There we go. Probably move this down. All right. Probably move that up a little bit. There we go. Something like that. Let's check, because I feel I want maybe some more easing in the camera as well. Maybe start a little bit earlier and have a little bit more easing. All right. And now let's go into our fluid. Maybe we want to pull out these frames so that this is going to last a little bit longer. All right. So let's press play. I guess I can just drag a little bit off the end. All right. Looking pretty good, I think. Let me increase the end a little bit. Probably want to move the camera down a little bit more. And after that, we're going to mesh the whole thing. So let me just go to the mover. Let's move it down a little more at the end. And I want to start it a little bit later. Right. I like it. Now let's do the meshing. It's going to be pretty simple. We can just use a regular particle fluid surface, similar with flip. Particle fluid surface. Add it on there. Let's reduce the particle separation. And we can increase the droplet scale a little bit. Let's reduce the influence radius. So it's going to be sort of just tweaking between the droplet scale and the influence radius. So influence radius is going to be how far is it going to look around each point to find something. And then a droplet scale is going to be scale of the droplet. And of course, droplet scale always has to be lower than influence radius. So particle separation, something like this. Looks pretty good. So, and oh, by the way, something we probably also want to do is that we want to add some velocity to this. So we're going to mesh this here. Problem is, our velocities are not going to match because we're retimed this. Only thing that's still not there on the Vellum solver, which I hope they're gonna add at some point. I read in the forums somewhere that they were gonna add this, is an ID attribute. And we don't have an ID attribute here. So there's a little bit of a problem. Because if we're gonna put a trail here in order to reintroduce some velocity. So velocity is gonna be used later for motion blur, of course, right? But because we're retiming this, you can see this stuff still looks like it's gonna move really fast, even if it's hardly moving. And if we put a trail here to say compute velocity, this is working fine. But it might break in the first couple of frames because there our point count is changing. So let's see if that's actually going to happen. Actually, doesn't look to be that bad. Actually, it's not as bad as I thought. I thought there was going to be a lot of trouble here. So I guess in this case it might be fine to just keep it like that. Else we would have to sort of fix it. I think here in the beginning it's a little bit too extreme. So if you just turn on velocity tools, you can see this is a little bit extreme. You probably don't want that. So let's manually override some of these velocities here. So let's put a wrangle, call it override V. Let's just say V at V times equals channel float. Just call it multi or something. I'm just gonna have a multiplier here for the velocity. Oh, probably. Oh, by the way, we probably want to do the trail after we move the thing down, because this is also going to generate velocity, the moving. Right. So here it's moving quite fast. It's correct. Maybe a little bit less extreme. Right, let's key. We probably want to reduce it here. And then after that, we want to move it inwards. Right. So now we have corrected our velocity a little bit by just multiplying it by a value there. So this is just multiplying our velocity. Right. And then when we're doing the moving here, the thing here is transferring our velocity. So that's looking good. Probably something we also want to do is we want to use some filtering to maybe smooth it out a little bit. So smooth here will sort of just smooth out the surface. Let's just cache this out and see how it's going to look. So let's just say $job. This new file cache is quite nice, like I mentioned before. Call it fluid mesh. And turn off simulation in this case, because if we're this is gonna use PDG in the background, so tops, in order to really utilize all of your available resources in order to cache this in the background. So meaning it's gonna cache multiple frames simultaneously. It's gonna make it a lot faster to write this out. So we don't need the entire range. Let's say, let me just have a quick look when it's going to be out of frame. So 1180-ish or 1080-ish. All right. So let's press save in background. You can see it's going to open up PG and it's going to work with a whole bunch of stuff at the same time. So I'm going to be back when this is finished. Oh, one more thing. By the way, if you save while this is running, it's going to ask this. Don't try to save while this is running. It's going to save before. And if you do this, frames are going to fail. So I just wanted to throw that out there while it was still running. Because what PDG, it saves sort of a copy in the background. And then it's going to run on that. And if you save it in the meantime, I've had it error before. All right, let me highlight this. So now we get a nice mesh. Let's flipbook this to see if it's actually stable, because we might need to fix some stuff if it's not. So there's still some small issues if we step through it. For the most part, it's relatively stable. There's just some parts where it's sort of jittery. So stuff like that. So we probably want to start addressing those. All right, so if we're gonna look through this thing, there's gonna be some individual points here that are free floating. I think those might be the issue. Let me just look through this. Because we probably want to get rid of individual droplets. I'm not sure if those are the main culprits. It looks like there's also some meshing issues that we need to fix, but let's first get rid of some individual droplets, because I think that might not be completely ideal. And that's just good practice, I guess, to filter out individual droplets anyways, and then you know how that works. So let's put a wrangle. Again, we're going to wrangle quite a little bit. And what we're going to do is we're going to look around each point, and we're going to sort of give it a radius. And we're like, how far can you look? And then store all of the points that you find in a list, in an array. Then we're going to check the length of the list. And if the length of the list is going to be too small, like really small, we're going to delete the points. So that way we can delete sort of small batches, or like small groups or individual points. Right. So let's say integer MPT array. So, and again, this is just a placeholder. This could be called anything. You could call this cheese, or you could call this whatever, but MPT, just near point. But if you prefer another name, just try to use something that's not native to Houdini. That's the main thing. And we're going to say equals near points, open bracket. Let's open up the help, so we can read it. Finds all the closest points in a geometry. Integer near points, that's what we already have. Which geometry itself, 0. Vector for the point is position, so at P. The max distance, so just let's create a slider, call it channel float and call it max dist. And let's do a channel integer max PT, so maximum points, close that bracket. And now we're going to get some sliders if we do this, and then you're not going to notice anything. So if you want to sort of read this out to see if it's actually working, might be good to say and I was just running at PTS equals NP, MPT equals MPT. Right. So I brackets at MPT, and I always mess this up in where I put these brackets, by the way, but this time it went fine. You can see now we created an array. So this is an array of all the neighboring points within this sort of radius. You can say how many can it find? Can it only find one? Can it only find whatever? So let's do just 5. Let's use a small radius, right? And we're going to say float len, just create a len, or you could do something else, but let's say float len equals len of npt. So this is going to be the length of the array. So let's just also write this out. Let's say I at len, or by the way, this could just be I integer len. Sorry, it doesn't need to be a float. So I at len equals len. So just check it out, what it's going to be. So you can see this array has 5, which is the maximum. You can see most of them are going to be 5, but a couple are 1. So those are probably the individual one. So 1. So if we're going to say, all right, if len is below 2, remove point, 0 point number. Control enter. All right, there you go. So let's look through our thing. So here you can see there's an individual point. And now it's gone. See, all of the individual points will be called out. So we could call this curl points. let's all these visualize things here that we have. Let's, by the way, put them at the end. Let's comment those out. Let's clean this up a little bit. So if you want to view it, you could do it. But let's just do 2 slashes at the front. So that's going to comment out those lines. Because you probably don't want to save them. Because if we're going to save these arrays, it's going to eat up more data. And we don't need to do that. So we probably need to remesh this. I probably, before I do that, I want to maybe change some stuff. Maybe I want the influence radius to be a little bit smaller. And let's make the droplet scale very close to the influence radius, like 4 or 5. It's going to be a little bit thicker, but I like them thick. And then let's press save to disk in background. And then, oh, by the way, maybe we want to, let's cancel this. We can see the difference before I start overriding this. Let's do it as a version 2. So we can sort of see the difference, might be better. Right, let's do save to disk in background. Gonna be back when this is finished. Right, so saved it out. Let's do another flipbook. So let's wait for that to finish. I think there's still very minor glitches, but this is a lot more stable than it was before. I guess you could keep playing around with it, like if you want to fix some stuff, but this looks pretty much fine. Like you see, there's some still some stuff there and there. I guess this is just playing. That's just gonna require some playing with influence radius, droplet scale. I'm gonna call this good enough for the tutorial. So let's address some of the other things that we need to do in this shot if we're gonna render this later. But for the most part, this is basically done. So we just have to address some of this stuff, like the environmental limes, need some UVs and things like that before we can throw this into a render later. So let's just very quickly do that. Environment limes. And probably we want to organize this a little bit. So let's copy some of these nodes here. Because we're going to reuse this model later. So it probably makes more sense to put this in an individual node here. Call it lime slice. Let's paste those things in there. Right. So let's have a look. So we're going to slice this up because this is going to return in a couple of shots, like also in the last shot, in the swirl shot there. So it's going to be good to save this out separately as well. And it's going to need some UVs. So we don't really need a color here in the center. That was just as a visualization. So let's first check what's going to happen if we just do UV project. So UV project will project some UVs. And if I'm just going to go select and then go to initialize, you see it will project it here. Let's also do it on the other one. That's going to be a different plane, so we also need to initialize. Let's see what that UV is going to look like. Let's, by the way, group this so we have some control over these insides. So let's call this insides. Right. And let's delete. Not selected. So the UV itself is looking pretty decent. We do have some of that stuff. Not sure if that's going to be an issue. Probably want to have this be a little bit more similar. Right, you know what? I'm just gonna UV layout this stuff. Put it on only the inside group there. And I probably want, let's select one of these islands. Let's move it. Oh, we don't want to do the entire thing. Let's see if we can. All right. Probably going to do it a little bit different. All right. Let's do inside 1 and inside 2. So we have some control. So we're going to do UV layout there on the inside. And we're going to UV transform on insides 2, maybe. All right. Yeah. Move it up. So we get some nice UV layout on that thing. So we have those things. Right. So now we have our mesh here. So still some stuff that we probably want to do here before the Boolean. So this is looking pretty terrible in terms of being a mesh. Probably want to try with a divide to add some extra geometry there. Let's see if I don't think it should mesh up our texture. It doesn't. Right. See if we can try to remesh this. Does it? I don't think it's necessary, but we can try. Let's put hard edge group to star. So it's going to use every edge group as a hard edge group. That's looking pretty good. So now I think this should all be one connected geometry, which it is, right? Then we have the UV stuff, which still works. Right, so now we have a nice slice here, which you can later use for rendering in Karma with UVs and everything. I guess you could still bevel these edges if you want to make this a little bit more smooth. I guess maybe we can do that. It should happen before the divide and before the other stuff even. Press 1, hold Alt, Shift, and then click. I guess we could say bevel. I'm not sure if this is going to look good, but I didn't do that originally, but I think, yeah, I mean, right, no, that's not gonna, I don't think that's gonna work. Right, let's just not do that. Right, so let's just keep it like this. Let's write it out as an asset. Rob geometry output. Let's just save it as a BGO. And what we're going to be using here is we're going to write it to $root/assets. So again, it's going to be our assets folder /models. And then I guess limeslice.bgo.sc with a small l. Save to disk. If we go to our project folder, you can see assets, models, limeslice. So we can later in other shots reference it in. Easy peasy, lemon squeezy. Let's hide it. And in our environment limes, instead of loading this thing, it's actually loading the file, which again was $root/assets/ and we can open the browser, just navigate to the models, limeslice. There we go. Let's delete these blasted points, or let's keep them. Probably want to scale this up. Just do a transform. I don't really need speed scale in this case. Right, let's see if I actually, I think this is looking fine. Let's put an output node. Let's do a light background just for our flipbook. Let's flipbook it again. Then we can write it out as a flipbook, put it in our edit, see how well it works. Don't forget, by the way, to make this a 1920 by 1080 flipbook. All right, there we go. Export, FFmpeg into the folder. Call it flip. Let's call it shot 030 v001.mpeg. Save it out. And good to go to try it in the edit. Right, so here in Premiere. So let's go to this shot, right click, review in project, right click, replace footage. Let's go to, that is not the correct folder. So let's go to the tutorial projects again. I don't understand why it always doesn't always remember where it should grab them, but hey, way to go, Adobe. All right, 3D, shot 30, flip, replace it with that one. You can see it lined out perfectly because our timing is the same. And then let's play. Perfect. All right. So that is shot 30. Looking pretty good. Of course, we're still going to light and shade and render it later, but this is going to happen in a later chapter. First, we're going to do all of the effects animation. If you were to do this in a bigger team, someone could start working on the lighting and shading for this one. Like that's something that would happen if you're doing this inside of a studio. Like the effects artist will have finished a shot, will export a whatever it is that you're using, a USD, an Alembic, BGOSC, whatever, hand over the Houdini file, depending on what the workflow is, and someone else will start lighting and shading it. In our case, we're going to do lighting and shading later. So let's now move to shot 20.